No, it is not permissible to bond the equipment grounding conductor, abbreviated EGC, at the receptacle to the neutral. The National Electrical Code, abbreviated NEC, Article 300.3, B states that an equipment grounding conductor shall not be used as a circuit conductor. The equipment grounding conductor is designed to carry fault currents back to the service panel, providing a path for electricity to flow away from the appliance or device in a safe manner. Bonding the EGC to the neutral at the receptacle would create a parallel path for fault current, bypassing the intended grounding path. This could reduce the effectiveness of the grounding system and increase the risk of electrical shock. No, bonding the EGC to the neutral at the receptacle does not accomplish the same as bonding the EGC to a grounding electrode. Bonding the EGC to the neutral at the receptacle does not provide a reliable grounding path. The neutral conductor is not designed to carry fault currents and may be overloaded or even broken during a fault, causing the grounding path to be lost. If you are unable to locate the grounding wire in the attic or walls, there are alternative methods for grounding the receptacle. Firstly, install a 3-prong receptacle adapter with a grounding plug that fits into an existing 2-prong receptacle. The grounding plug will contact the metal box, providing a grounding path. Secondly, plug a grounding outlet tester into the receptacle. If the tester indicates the receptacle is not grounded, remove the receptacle and install a new one with a built-in grounding terminal. Connect the EGC from the cable to the grounding terminal. Thirdly, install a ground fault circuit interrupter, abbreviated GFCI, outlet. Ground fault circuit interrupters provide protection against shock even if the receptacle is not properly grounded. However, they do not replace the need for a grounding path. It is important to have the grounding system inspected by a qualified electrician to ensure it meets code and provides adequate protection. The equipment grounding conductor provides a low impedance path for fault current to return to the source. This low impedance path is crucial for quickly tripping a circuit breaker or fuse during a fault, minimizing the duration of the fault and reducing the risk of electrical shock or fire. Bonding the EGC to the neutral creates a parallel path, potentially increasing the impedance of the fault current path. This can slow down the response time of the overcurrent protection device, increasing the risk of harm. Furthermore, the neutral conductor is designed to carry and balance current under normal operating conditions. It is not designed to handle large fault currents. If a fault occurs and the EGC is bonded to the neutral conductor may become overloaded, leading to overheating and potentially a fire. In addition to the safety concerns, bonding the EGC to the neutral violates electrical codes. The National Electrical Code specifically prohibits this practice. Violating electrical codes can result in fines, penalties, and legal liability. When dealing with electrical systems, it is essential to prioritize safety and adhere to established codes and standards. Improper grounding can have serious consequences, including electrical shock, fire, and equipment damage. Therefore, it is crucial to understand the proper grounding techniques and to seek the assistance of a qualified electrician if you are unsure about any aspect of your electrical system. The ground fault circuit interrupter is a safety device that protects people from electrical shock. It works by monitoring the current flowing through a circuit. If it detects a difference between the outgoing and returning current, it assumes that some of the current is leaking to ground, which could indicate a shock hazard. The ground fault circuit interrupter will then quickly trip the circuit, cutting off the power and preventing a shock. Ground fault circuit interrupters are commonly used in areas where there is a risk of water exposure, such as bathrooms, kitchens, and outdoor outlets. They are an important safety feature that can help to prevent electrical injuries. While ground fault circuit interrupters provide shock protection, they do not replace the need for a properly grounded system. Ground fault circuit interrupters do not prevent damage to equipment or reduce the risk of fire caused by ground faults. A properly grounded system provides a low impedance path for fault current to return to the source, which helps trip the circuit breaker or fuse and clear the fault quickly. When troubleshooting grounding issues, it is important to use appropriate test equipment, such as a multimeter or a ground loop impedance tester. A multimeter can be used to measure the voltage between the EGC and the neutral conductor. In a properly grounded system, this voltage should be close to 0 volts. A ground loop impedance tester can be used to measure the impedance of the grounding path. This measurement can help to identify any problems with the grounding system, such as loose connections or corroded conductors. If you are not comfortable working with electricity, it is best to call a qualified electrician to troubleshoot and repair any grounding issues. Working with electricity can be dangerous, and it is important to take precautions to avoid electrical shock or fire. A qualified electrician has the knowledge, skills, and experience to safely and effectively diagnose and repair electrical problems. Electrical codes and regulations are in place to protect people and property from electrical hazards. These codes and regulations specify the minimum requirements for electrical installations, including grounding systems. It is important to be familiar with the applicable electrical codes and regulations in your area and to ensure that your electrical system complies with these requirements. Failure to comply with electrical codes and regulations can result in fines, penalties, and legal liability. It is important to understand the difference between grounding and bonding. Grounding is the process of connecting an electrical system to the earth. Bonding is the process of connecting different metal parts of an electrical system together to create a low impedance path for fault current. Both grounding and bonding are essential for electrical safety. Grounding helps to stabilize the voltage of the electrical system and to provide a path for fault current to return to the source. Bonding helps to prevent voltage differences between different metal parts of the electrical system, which can reduce the risk of electrical shock. When installing a new receptacle, it is important to use the correct wiring method and to make sure that all connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to a fire. It is also important to use the correct size wire for the receptacle. The wire size should be appropriate for the amperage rating of the receptacle. Using undersized wire can cause the wire to overheat and melt, which can also lead to a fire. When replacing an existing receptacle, it is important to turn off the power to the circuit before working on the receptacle. This can be done by switching off the circuit breaker or removing the fuse that supplies power to the circuit. It is also a good idea to test the receptacle with a voltage tester to make sure that the power is off before we start working on it. This will help to prevent electrical shock. When working on electrical systems, it is important to wear appropriate personal protective equipment, abbreviated PPE, such as rubber gloves and safety glasses. Rubber gloves will protect you from electrical shock, and safety glasses will protect your eyes from debris. It is also important to work in a well-lit area and to avoid working in damp or wet conditions. Damp or wet conditions can increase the risk of electrical shock. If you are unsure about any aspect of electrical work, it is best to consult a qualified electrician. A qualified electrician has the knowledge, skills, and experience to safely and effectively perform electrical work. Attempting to do electrical work yourself without the proper knowledge and training can be dangerous and can lead to electrical shock, fire, or other injuries. Always prioritize safety when working with electricity. By taking the necessary precautions and following established codes and standards, you can help to prevent electrical accidents. Remember that electrical systems can be dangerous, and it is important to treat them with respect. If you are ever in doubt about anything, consult a qualified electrician. A qualified electrician can provide you with the information and assistance you need to safely and effectively maintain your electrical system. The size of the equipment grounding conductor is determined by the size of the overcurrent protection device protecting the circuit. National Electrical Code Table 250.122 provides guidance on the minimum size of the equipment grounding conductor based on the rating of the circuit breaker or fuse. For example, for a 20 amp circuit, the minimum size equipment grounding conductor is typically 12 American wire gauge copper. It is crucial to refer to the NEC table for the specific requirements based on the overcurrent protection device rating. Proper installation of grounding electrodes is also essential for a well-functioning grounding system. Grounding electrodes, such as ground rods or ground plates, provide a connection to the earth, which helps to stabilize the voltage of the electrical system and provide a path for fault current. The National Electrical Code specifies the requirements for the type, size, and installation of grounding electrodes. Ground rods, for example, must typically be at least 8 feet long and driven into the ground until at least 8 feet of the rod is in contact with the earth. The location of the grounding electrode should be carefully chosen to ensure that it is in contact with conductive soil. The resistance of the grounding electrode should be measured to ensure that it is within acceptable limits. A high resistance grounding electrode may not provide adequate protection. Regular inspections and maintenance of the grounding system are important to ensure that it continues to function properly. Grounding connections can loosen over time and corrosion can develop on conductors and connections. These problems can impair the effectiveness of the grounding system. Grounding connections should be inspected periodically and tightened as necessary. Corroded conductors and connections should be cleaned or replaced. The grounding electrode should also be inspected to ensure that it is still in good condition and that the resistance is within acceptable limits. If any problems are found, they should be corrected promptly. When installing electrical equipment, it is important to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide guidance on the proper grounding methods for the equipment. Some equipment may require special grounding techniques, such as the use of isolated grounds. It is important to understand the grounding requirements for each piece of equipment and to follow the manufacturer's instructions carefully. In some cases, it may be necessary to install a separate grounding conductor for sensitive electronic equipment. Sensitive electronic equipment can be susceptible to damage from voltage surges and other electrical disturbances. A separate grounding conductor can help to protect this equipment from damage. The separate grounding conductor should be run directly from the equipment to the grounding electrode, without any splices or connections. This will provide a low impedance path for fault current and help to minimize the risk of damage to the equipment. When working with electrical systems, it is important to be aware of the potential hazards and to take precautions to avoid electrical shock, fire, or other injuries. Always turn off the power to the circuit before working on any electrical equipment. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Work in a well-lit area and avoid working in damp or wet conditions. If you are unsure about any aspect of electrical work, consult a qualified electrician. By following these safety precautions, you can help to protect yourself and others from electrical hazards.